Good morning, students. Today we will be learning about the landforms created by the river in the upper, middle and lower course. The learning objective for today's lesson is you will be able to identify the features a river creates in the upper, middle and lower course, and you will also be able to differentiate between each of the features created by the river at the end of the class. So now we will be learning about the landforms in the upper course. If you can look at the diagram, the landforms which are developed in the upper course by the river are the V-shaped valley, the interlocking spur, the I-shaped valley or canyon, and waterfalls. So students, we will first learn about the V-shaped valley. So look at the first image over here. The river begins high up in the mountain, so they flow quickly downhill, eroding the landscape vertically. That means downward cutting. So next, what is happening? The river cuts a deep down cut into the landscape, causing hydraulic action, that is corrosion and corrosion. Now look at the second image, students. As the river erodes downwards, the sides of the valley are exposed to freeze-thaw weathering. We have learnt about this in class 9. So what happens with that? It loosens the rocks and it steepens the valley sides. The rocks which fall into the river help the process of corrosion, and this leads to further down cutting. And finally, we have the shape of a V-shaped valley. The river transports the rock downstream and the channel becomes wider and deeper, creating a V-shaped valley. So this is how a V-shaped valley is formed. It basically flows very fast from the mountain. It wears away the riverbed, and the active downcutting process leads to the V-shaped valley along with lateral corrosion and side cutting. The next feature is the interlocking spur. Students, this is a very simple feature which we can see in the river. So this happens when the river is coming down. Does the river flow straight? No. It will twist and turn around certain obstacles. So over here, when we see that the river is twisting and turning, and it bends and it avoids the hard rocks. This creates the interlocking spur, which looks a bit like interlocking part of a zip. For example, students, if you can see, I'll just point out with a laser over here, so it will be helpful for you all. The river is starting from here, correct? This red point, it starts from here. It is bending these ways. So these are my hard rocks. These things which are standing are my hard rocks. So what is the river doing? The river is cutting the softer parts and leaving the hard rock standing as it is. So it stands like a concave bank. So this concave banks are known as your interlocking spur. So in short, if I ask you what is an interlocking spur, you will simply say that when the river erodes the landscape in the upper course, it twists and turns to avoid the hard rock. This creates interlocking spur, and you have to give this diagram. The next important feature of a river is the waterfalls. So students, how is the waterfall created? Now when a river waterfalls suddenly from a great height, okay, but what is it happening? We all know that rocks are made up of soft rocks and hard rocks. So therefore the river starts eroding the soft rocks. Therefore what remains is the hard rock which stands hanging, as you can see in the second image over here. The first image we can see that normally the river is flowing and it is called a rapid, correct? Now what is a rapid? In the mountain course where there is frequent change of slope, hard and soft rocks may remain vertically against each other. The softer rocks are eroded faster than the harder ones, which stand out as outcrops. That means they are standing outside. So when the water is coming down, it jumps on these hard rocks. These are called your cataracts, it's called your rapids, and a series of rapid is called your cataract. So we can see in the first image a rapid. So if this continues, it becomes a cataract. Now in the second image, we can see how this soft rock has got eroded. Can you see this soft rock has got eroded, and what is standing is my hard rock. So this water will eventually overhang the hard rock. If it is overhanging the hard rock, it falls down, and because of the process of corrosion, again it creates a plunge pool over here. This plunge pool is created because of corrosion. We have studied what corrosion is. It is eroding, and therefore finally what we have is a waterfall. So we find that the water is falling from this hard rock, it is coming down into the plunge pool, and this is what we see as the waterfall. There are very famous waterfalls, the most famous being the Niagara Falls, which is in North America. We also have one in India, the Narmada Falls, which is at Jabalpur on marble rock, presented with a beautiful scenery. Now students, you must know that the plunge pool which forms beneath it is actually a pothole, which is also created by the process of corrosion. So the last one which we'll be doing is the eye-shaped valley or the canyon. Canyons are very simple and they are followed mostly after a V-shaped valley or gorge. So what is a canyon? A canyon is formed when a V-shaped valley is further down cutting takes place. Okay, so vertical erosion takes place and the steep sides of the V-shaped valley becomes thinner and it becomes like an eye-shaped valley. So when further down cutting in a gorge takes place, we find that an eye-shaped valley is formed, and there is a very famous eye-shaped valley or a canyon which is carved by River Colorado. It is called the Grand Canyon. Apart from that, we also have one in India which is found in River Krishna, which has carved a deep canyon near Mahabaleshwar. The last feature in the upper course is potholes. Now, how are potholes created, students? Usually when the river moves very swiftly, we find that at the bedrock, because of the process of corrosion, round holes are formed. These potholes are deepened when the round stone, which the river is carrying as a load, keeps on boring. Boring means it is turning and deepening it into the base of the hole as the river moves. So if you can see in this image, students, this is, we can see a load over here. Now this load is going on turning. Can you see the arrows? It is going on turning. When it is turning, it is deepening the river bed, and ultimately if you can look at the right side, we will find that we have holes like this created on the river bed. These are called potholes. The landforms in the middle course. In the middle course, there are three main landforms: the meander, the oxbow lake, and the floodplain. The first feature of the river in the middle course is meander. So what is meander, students? We all know that the river does not flow in a straight line. So it moves in a zigzag manner. This zigzag manner is called meander. So while the river is meandering, what is happening? The outer side of the channel, which is hit by the river, is eroded, and the inner part of the bank gets the deposition of the eroded material, and this zigzag motion of the river is called the meander of a river, which is found in the middle course. Now students, the next feature is the oxbow lake. This is formed after the meander. So we know that the river is meandering. Now what is happening is, while the river is meandering, the outer bank keeps getting eroded and it assumes almost a circular shape, as you can see in the first image. At one stage only, a narrow neck of land separates the two concave outer bank, which we can see in the third image, that how this narrow neck has been separated. Please look at this image where this neck is separated from the main river. The big loop is cut off from the river channel due to heavy deposition. So we can see that when deposition is taking place, what is happening? Finally, this loop is cut off, and that is exactly what we can see in the third image. The abandoned bend of the river remains there as a lake which looks like a horseshoe or a oxbow, and this is known as your horseshoe lake or your oxbow lake. Now students, the floodplains of the Ganga, the Wangho, etc. have oxbow lakes on them. The last feature in the middle course is the floodplain. Now students, this floodplain can be seen in the middle as well as the lower course, but typically it is seen at the end of the middle course, starting of the lower course. Now what happens in the floodplain? As the name suggests, it is found when the river floods. So it takes place on the riverbed, and in rainy season when flood occurs, there is widespread deposition of alluvium that takes place. This gradually fills up the areas, that is both the banks, the right bank and the left bank. Now this is basically your flood plain. They are well developed along the middle as well as the lower course of River Ganga, Wangho, Yangtze and various other major rivers of the world. Now students, we find that this floodplain is also a place which is densely populated. Now students, we will be studying about the landforms in the lower course. As we all know that in the lower course the main work of the river is deposition. So let us see the first feature that the river will make out of deposition. It is called a natural levee. Now students, what is a natural levee? Usually we said that deposition is very active in this level. So what happens? Long period of deposition takes place and then the river banks are raised. If you can see over here, these are your river banks. This was before the flood. This is the second image is after the flood. So we can see this is the raised river bank. And in the third image, we find that the river bank is more raised over here. So now these raised banks which are naturally raised because of flooding are called your natural levee. Now sometimes the flood water breaks through these levees and bring devastating floods. But most of the time these natural levees are a source of protection from the floods. Now many rivers at the lower courses have these natural levees such as Ganga, the Wangho and the Yangtze. Usually it minimizes the risk of flood and the artificial embankments are sometimes erected on these natural levees to give them a strong protection. The next feature is the estuary. Now students, the estuary is basically formed when a river does not have too many tributaries. It is a straight flowing river. So what happens? They are usually of tidal origin. So the sediments that they carry are washed by the tidal waves into the open sea. And so the mouth is usually funnel shaped and they are free from sediments, like in the case of a delta, which we will be studying in the next slide. Now estuaries are of also various types, but for your class you need to know that they are when a river meets directly the ocean or the sea without having any tributaries or distributaries, or the number of tributaries and distributaries are less, and they are of tidal origin. They are free from sediments. Example of an estuary we can say in India, we will find it in river Mandovi, and it has an estuary in its mouth. The last feature of the river in the lower course is a delta. Now students, in the lower course we find that when a river becomes extremely slow and sluggish, so what it does with the load that it is carrying, it starts depositing that load. So the deposition sometimes builds a fan-shaped alluvial cone which often looks like the Greek letter like a V, okay, like a delta, like a triangle. Now this delta is formed at the river mouth when it is depositing, And as the deposition goes in the river mouth, the river is forced to divide into several channels. Now these channels are your distributaries and they become a large delta. We have the largest delta in the world, which is the Ganga-Brahmaputra delta. Now we will learn of the various types of delta. Students, there are typically three types of delta that we will learn about. Let us see the three types of delta. The first type of delta is called your arcuate delta. So what is an arcuate delta? If you can look from this image, let me just get the laser for you. This image is the arcuate delta. See, if you can look over here, it actually looks like a triangle. This triangle is your Greek alphabet called delta. Now it looks like a triangle, and the largest is the delta of Ganga Brahmaputra river. Nile delta is also an example of an arcuate delta. The next one we have is the bird foot delta, this one. If you look at it, it looks like a bird's feet, correct? So what is this? This delta is found in the Mississippi River. The delta looks like a bird's foot with several main branches extending into the sea like the foot of the bird. So we can see so many extra branches have been coming out from it like a bird's foot. The other name for this type of delta is the digitate delta. And the third one which we have is the cuspate delta. Now what is the cuspate delta? It is formed when the river drops sediments into a straight shoreline. See, we can see that the deposits have been dropped absolutely straight. There is no division like in an arcuate delta or a bird foot delta. So what happens over here? It is formed by a lot of sand and shingle when they deposit in a straight tooth-like projection or a mouth. It is called a cuspate delta. An example of such a delta is the Ebro of Spain. Students, this is a quick understanding of the difference between delta and estuaries. This will help you to understand, and if you have any doubts regarding how a delta is formed and how an estuary is formed, this river will give you, this table will give you a clear understanding. Also on page 8 of your textbooks, it is clearly mentioned what are the conditions favorable for the formation of delta. So if we can discuss a few, we know that the river has to be very active in the upper course. It has to it must be a part of vertical and lateral erosion. It must have a lot of tributaries and distributaries. It should be carrying a lot of load to build up the sediments. It should have strong currents at the river mouth to wash away the sediments, and the slope of the coastal areas should be so gentle that it can enable the river to become sluggish and deposit the sediments. So these are some of the conditions that favors the growth of delta on the mouth of any river. Thank you, students. If you have any doubts or queries regarding the portion that we have covered, please feel free to to mail me at reema.sma@outlook.com. I will be sending you the homework, so you can please follow up with your homework and extended learning as well. Thank you.